Good evening. I hope you've had a great day.
Wow, that was easy.
Yeah. Thank you.
Can we go now?
Go and have a drink.
We're going to talk about where we think we're going, where the future is. So maybe a good place to start is, where do you think we are?
It was Copenhagen last time I checked.
Yeah. As a software industry.
I think we're starting to get to somewhere that is really pleasingly boring. And I think it's taken us a really long time to get here. But one of the things I love about all of these, and I'm on the LinkedIn's quite a lot, all of these Agile is dead kind of posts, is Agile is dead because it's just kind of mostly normal now. Right? I mostly go into organizations and mostly go into organizations and mostly people are working in teams. And mostly if they need to do work, they don't need to fill out a form and send a request off to a DBA team. And they mostly don't need to send another form off or fill out a design thing to go to a UI team. So, cross-functional teams are just kind of boringly normal now. I don't remember the last time, and it may be a selection bias, right? But I don't remember the last time I went into an organization that was doing 18-month releases, right? Or even, yearly.
I can introduce you to some.
Yeah, Dave probably knows a few. But, okay, they're not great, but quarterly releases is still pretty good. Mostly monthly releases, sometimes on demand, right? I love that the stuff that Martin, or the picture's not up there anymore. Martin and I were on a panel. I have to share this, actually. That panel was 20 years ago, almost to the day, at Yao, which was the precursor to GOTO, in Aarhus. And this T-shirt that I'm wearing is from 2006. I don't have the 2004 T-shirt, but this is the 2006 T-shirt. We were on a panel, and the panel was about process, about software process. And the lovely gentleman at the end was from the US Department of Defense. And we were fairly convinced he could have people disappeared, right? And what he was doing, the reason that the horrified looks are there is that he was saying, well, you need all of this process, and you need these gates, and you need these. And Martin, in his completely non-confrontational and non-controversial style, said, no, you don't. Don't need any of that. At which point he looked like someone had just poked him in the eye with a badger. And that's the moment. The moment that captures is him going, how very dare you? and it was lovely. And I remember later on in that same panel, because Martin was being Martin, but more so. And at some point, it goes out to the audience and someone said, Martin, I have a question. Have you ever been fired by a client, right? You're saying some pretty controversial things. And he's like, well, no, I've never been fired. And apparently, 20-something-year-old me grabs the mic and goes, I have. That's my endearment. So 20 years, let's bring the arc forward 20 years. Yeah, things that I love, it's not dead, it's just wet like fish, right? It's just kind of in the fabric now, which means that we can now go after the really interesting stuff, which is how do you generate value in organizations. Now we've gotten a lot less rubbish at the software bit.
I'm going to disagree with you.
Yes.
I agree with you from the Agile point of view. But what I've been thinking about a lot, because I think about developer productivity, and I do stuff with the IDE and Java and stuff. And when I started...
How to name it.
What, Java or IntelliJ?
Yeah, you go.
Please buy my book. Buy all of our books. So when I started as a developer, around about that time, 20-odd years ago or something, I was a Java developer, and you sit down in front of the IDE and someone hands you a piece of paper and says, this is what you're going to code, because it's called a technical specification, which half the people in this room has never seen in their lives. And then you would write code, and then someone else would test it, and someone else would release it, and all you're responsible for is writing code. One of the good things about the way the industry's moved on is that we do way more stuff now, and we're in control of way more things, and we've got continuous delivery, and we're doing things like Docker stuff and Kubernetes stuff and DevOps and security is DevSecOps and all of these things, and talking to the business, because Agile is good and we talk to our customers. But now as developers, we do so much. We do almost no coding. We do all of this other stuff. And it's good because it brings us closer to the business. It helps us to deliver stuff faster, the right stuff faster. But it also puts a lot of pressure on us as developers to worry about everything that used to belong to specialists before. And now a junior coming into the industry has to know freaking everything, and they get taught nothing at universities about these kinds of technologies, because that's not what a university course is for. So while Agile has become boring and normal, and that's great, I think the pressure on us as developers has just increased over the last 20 years.
And yeah, I'm inclined to disagree with you as well, Dan.
I'm loving this panel, honestly. It's my happy place.
And
Just listen to Holly, and then Martin's going to disagree with me.
And me.
Because I think you're 100% right, that the practices have changed, and our stack has changed, and some of the terrible things that we used to have to do have gone away. But now we have new sets of terrible things that we have to do. And if you ask anybody what do they love about their job, you tend to get this sort of fairly standard answer, which is, it's the people. And then you ask them what they hate about their job, and they think about it for a moment, and then they say, it's the people. And I'm not aware of any of this research, but I would love to interview a software engineer from 20 years ago and say, how happy are you at work? And then interview a software engineer from now and say, how happy are you at work? And I would guess the answer is about the same. Because even though so many of the details have changed, the fundamentals of you have too much to do, you don't know how to do it, and other people are annoying, are actually exactly the same. And if I'm honest, depressingly, no matter how many of these conferences we go to, I don't think we're going to be able to solve that problem. Sorry, GOTO.
I have another thing to add to that, though. I think our expectations of being happy now are much higher than a software developer 20 years ago, who would turn up and do a 9 to 5, and it's okay to be dissatisfied with your job, because that's what work is like. And now we're like, well, I don't really want to be dissatisfied with my job, because I have to work all the hours that God sends and be on Slack at 8 o'clock in the morning, and I would rather not do a job that I hate.
Yeah, I mean, it's hard for me to say because I'm so detached from the day-to-day of software development these days. You know, I talk to people who talk to people who talk to people who are on software development teams. That's about as close as I get. So with that caveat, though, I don't get the sense that Agile is present everywhere. The name Agile is present everywhere, but the actual practices and philosophy and all the rest of it that we talked about at Snowbird is still only patchily around, because what's happened is that the name got a lot of attention, but what we're seeing is things like SAFe and other forms of faux Agile that aren't anything like the real thing. What I think, however, I do get the sense that things have improved significantly over the last 20, 30 years, and I'm going 30 years because I first got involved with Jao back in the 90s, so I can play I've been here 30 years, almost 30 years card. Not quite 30 years, but at least 25. Definitely feel we've seen progress. I mean, we are at the point, but also a lot of the things that we're saying now aren't as shockingly revolutionary new as they were then. So it's kind of less exciting to be saying things like, hey, you don't have to release every year, and even every 2 months is actually a bit slow in our opinion. Which was probably where we were 20 years ago. But now there are plenty of places out there that are actually doing that kind of stuff, but it's not evenly distributed. And there is still a lot of stuff that isn't quite there. But I feel we have made some good progress, and there are a lot of places that are doing really good stuff. I mean, one trip I did have was to one of our clients in Hamburg that's been going 10 years, doing some really great stuff with all this kind of the kinds of things that we talk about and we like to do. And then I get shuffled into another meeting with another department of the same organization, and it's like I've gone back 20 years in time. And it's a whole different, how can that possibly work kind of stuff, except, hey, this part of your company has been doing it for 10 years. So even within organizations, you can get this sort of huge time drift happening. So But then I never expected huge progress. I'm the kind of person who, to try and get the kinds of changes we're talking about cause societal shifts, shifts in power structures. These things do not happen quickly. They take generations. And so, yeah, I would love it to be moving faster, but I'm actually kind of pleased it's moving at all.
Okay, I'm going to do the opinionated moderator thing now and kind of sum up some of this stuff. So I kind of think that Dan's right that we're just wet fish. It's just it's pervasive now. The assumption that if you ask people that how do you develop software, they now believe that the right answer is Agile, and then I believe with everybody else is that most of them aren't doing it. So it's kind of a problem. But the other thing that I notice, I'm kind of interested in sort of the engineering end, sort of the extreme programming end more than the Scrum end of the conversation, really. And I do believe that certainly amongst people like us, people that talk at conferences, the people that I meet, the clients that I talk to, there's an assumption that goes a bit deeper than just we're pretending to do Agile, but the stuff that we talk about, they believe to be right. It's just too hard for them to do.
So I've been thinking about this, and I've been ridiculously indulged at this conference because I've got to hang out with Kent Beck, who's absolutely one of my heroes, and I've known Martin for north of 20 years. I'm still in awe of the guy. I get to hang out with these incredible brains who did really cool stuff and who are still doing really cool stuff. And I sort of had a bit of an epiphany. It might have been an epiphany. It might have been like a background hamster thing that's been going for a while.
The beer.
It might have been the beer. Although, I don't know who's organising this, but point of order.
Out of beer exception.
Out of beer exception. Is this. If we go back to Snowbird, let's take it right back to the beginning of the manifesto for Agile software delivery happened in a ski resort in Utah 20-odd years ago. And what happened was a bunch of folks came into a room with what was then called lightweight software methods. And a big part of the kind of call to action, the call to arms, was lightweight doesn't really carry. It's really hard to go into a C-suite or senior folks in an organization and pitch, we're going to do a lightweight method. It didn't really have the cachet. We need a thing. And the thing that came out was the word Agile. And that wasn't even the first choice. The first choice was adaptive, but one of the other folks there, Jim Highsmith, already had a thing called adaptive, and so they couldn't really, he said, they said, we don't want to take your brand. I'm paraphrasing, but so Agile was the word that came out of the room. The problem, or the thing I realized, and I've been fairly vocal on some of the social medias out there about this for a while, is if you look at Scrum, the methods that came into the room were lightweight. Not all of the methods in the room were Agile. Mm-hmm. Scrum is immutable. Scrum sells itself that if you're not doing all of the bits of Scrum, you are not doing Scrum. It talks about inspecting and adapting, but the thing you inspect and adapt is the backlog, and only the product owner is allowed to do that, right? You're not allowed to inspect and adapt the process, which is the least Agile thing I could imagine, given that you're supposed to prioritize people and interactions over processes and tools. And it's the one that became pervasive because certification, Agile, industrial complex, right? So now suddenly the world is doing this thing called Scrum, and then the same people who like to buy a solution that has a brand now want to buy a scaling solution, and the folks who used to sell RUP suddenly saw their market disappear with the Agile folks, and so the same people who sold RUP created SAFe and DAD, disciplined Agile, and less, and all of these other Scrum at scale, and all these things. The people behind these are the same as the people who are selling RUP. So we're kind of in this place where all these people are adopting these methods, and Martin's absolutely right. There is zero agility in any of those methods, and we're surprised that things aren't becoming more agile.
But just to look on the slightly more optimistic side,
We're doomed, Dave. We're doomed.
You don't have people like the man from the Department of Defence at a conference like today saying we should all have heavyweight process and write it all down.
No. What he's saying now is we should all have release trains and have you bought my certification.
I know. It's it's nearly as bad, but it's slow. No, I think.
There may be lots of people out there who says you've got to do Scrum exactly by the book and not change anything, but I don't think you'd find people like Ken Schwaber or Mike Beadle or Jeff Sutherland agreeing with them.
Okay, let's move on, because we promised that we would talk about the future. So if that's where we are, where are we going?
I have thoughts, but I've heard too much me, so I want to hear something else.
Yeah, see, I have a non-thought, so I hesitate to go first because this is too boring. But I'll go first, and then you can all disagree with me since we did that to Dan, which is because I rather cynically said nothing has changed from the past, and so I can extend that to the future and say, if you ask a software developer in 20 years, what's their job like? They'll say, people are annoying, and my boss has taken this really simplistic version of whatever the latest thing is, and they're doing it wrong, and people are annoying. And computers are worse.
So just as a starting point, given the elephant in the room that we haven't mentioned yet, that something's happening in machine learning.
We're burning a planet. I'm not sure what else we're
given that, you've already made an important statement, because there's an assumption that there's still going to be software developers.
Absolutely, because if you look at what are the most interesting, challenging parts of our job, it is not the tappa. It is understanding the requirements. It's negotiating with those annoying people. Did I mention people are annoying? It's the teamwork, and that is very difficult to automate away. And I think as well, when we look at jobs that have been obsoleted, there was a finite demand for the service. And my favorite example of this is there used to be a job in the industrial UK called a knocker-upper. And what a knocker-upper did was they had a very long stick. And the problem that people had was that they had factory jobs. They had to start at whatever time because they needed to be on shift. They didn't have alarms because this was a long time ago. And so they would employ the knocker-upper to go around with a long stick and tap on their window. And this actually stayed as a viable profession until the 1940s and until the 1970s in some parts of England, which is a different conversation. But the point with a knocker-upper, which got obsoleted by technology, is there is a finite demand for getting woken up in the morning. Ideally, you would have 0 wakings up in a day. But at a bare minimum, if you need to go to work, you get woken up once. You do not say, I got woken up and I enjoyed the experience so much, could you wake me up again and again and again? The demand is limited. Whereas with software, what we tend to find is that we have a bit of software and we go, you know what? I need more software. And then we get back to that XKCD scenario of I need software to manage my software, and my software is out of control, so I need DevOps software to manage my stack, to monitor my deployments. And then it just spirals and spirals, and we are the happy people who have those skills to continue producing software. So I have no worries about the demand for software, other than the worry about the demand for software.
Yeah, I'm kind of with you on that in the sense that when I got into the software industry, I was told that there was no real future in programming because either 4GLs or case tools were going to do it all for us.
Yeah.
And we saw how well that worked out.
Yeah. Does anybody remember?
And of course, there was a time before when people said, yeah, there's not going to be any use for programmers anymore because COBOL's going to appear. And we won't need programmers. So that cycle is, I think, more likely than not to repeat. What may interestingly change is what will certainly change is the kinds of things we do as programmers. And I think there are some interesting elements here in things like what's happening with some of the AI tools that could really cause some shifts. It was interesting, I was having a conversation with someone recently about this. Many people like to make sort of metaphors and analogies between software development and something that isn't software development in order to explain software development. And I have as far as I can tell, seems to be a unique metaphor to use, but I still feel is one of the most accurate. I think the most accurate metaphoric non-software profession to software profession is law, specifically the drawing up of laws. either a legislator drawing laws or a judge interpreting laws and effectively drawing up opinions, or more commonly, contract lawyers agreeing a contract between companies. Because what lawyers do is they have to construct some set of rules that govern future behavior. The difference, of course, is that while we work with deterministic computers, they work with non-deterministic human beings and companies and societal structures. And I still think that's a great metaphor and an analogy to use, because I think a lot of people can get that sense of that from the way the law works. But of course, one of the interesting twists is that as you bring in these kinds of AI tools, suddenly maybe we're going to have to start to learn a bit more about programming for non-deterministic systems. And how does that fit in with the deterministic ones that we're used to? Could be.
That's an interesting thread that I fancy coming back to. But
I was going to say about, come back to something that you said about being a software developer is not about typing the code, and this is something that you taught me. And when we talk about things like Gen AI generating the code for us, and we won't need programmers anymore, and all the rest of that stuff, it's like you said, it's the same thing as they said about next generation languages and IDEs. The IDE will make you lazy. If you use an IDE, then you're not a real programmer anymore. It's like, no. It means that I can actually do the real work of programming, which is the thinking and the communicating with the stupid people and hopefully writing tests, which people still don't freaking do. And the testing thing, I mean, you could get Gen AI to write your tests for you, but that's the wrong way around, because all that's going to do is generate tests that prove the code you wrote does what you did, instead of thinking, what should it do? What is the expected behavior? And that's the thing that you're supposed to be thinking about, and that's why testing is hard, and that's why Gen AI isn't going to do that for you.
And that in its own right is a technical discipline, trying to break the problem down in that way.
Right. Exactly, and that's what we need people for. Yeah. Right now, that's what we need people for, and we will continue to need people for that.
Well, that's where I think some of the Gen AI stuff is interesting, because Gen AI tools are very good with coming up with first drafts and ideas. They're not very good at coming up with final answers. So, in testing, I mean, I'd be interesting, throw Gen AI, I said, give me 10 tests that should fail against this code. And 9 of them would be, well, they damn well should fail, but one of them might, if one of them is, ooh, then you're ahead of the game, right? I love that one of the earlier speakers at the conference talked about using AIs to come up with metaphors. Give me 3 metaphors that would explain this to a financial analyst. I mean, that's the kind of stuff, raw ideas that we then kind of shuffle and work with. And that seems to be where it's one of the areas that it is actually interesting at the moment. I mean, we're doing some of that, I don't know full of detail. We're doing some in-house stuff with this kind of thing, of coming up with scenarios to test with domain experts. Give me some storyboards. And then you go, they're not expected to be final, they're expected to be a starting point. Or some people try security stuff, say, hey, apply the stride criteria and give me a whole bunch of threats. And again, they're not all going to be accurate. Most of them won't be, but if some of them will, then it's worth it.
Well, and then you've got the trade-off of, is it more work to wade through the chaff to get to the wheat than to actually do a different thing that would have got you the same wheat? I was thinking about metaphors, and you're talking about your law. A metaphor I've been using for software for a while is surgery. And the reason I use the metaphor of surgery for software is no one wants surgery. That's my start. No one wants surgery. What they want is the thing that surgery gives them, which is to be well.
Yes.
Right? So if they need surgery, they want the least possible surgery they can get away with. They want to be operated on by someone who's done surgerying before. They're not learning surgery on them, right? Ideally, they want them to be doing surgical procedures that are well-known, repeatable, have research in them, and so that if it's going to be a hernia or a heart bypass or whatever it is, that thing is well-known. You're not making it up in my body, right? And also that if another surgeon comes along later and looks at it, goes, oh, I can see exactly what that was about and why you did that. And also the way you did that tells me that there was something...
Surgeons leave comments.
Yes, they do. Funnily, yes, they do. That's a whole other story. Yes, they do. I know a surgeon who, apparently when you operate on livers, you etch your name, so your initials. True story. So, it wasn't my liver. But the point being, right, what I say, I look for edge. I look for differentiators. And I'd like to think in the future, the differentiator will be the organizations, the teams, the people who can solve the thing with the least possible software. So I don't want LLMs generating software. No one says I want more surgery, right? I'm paying for surgery. I want you to cut me open and do all the things, right? No, said no one ever, yeah? I don't want more surgery. What I want is the equivalent of, and someone described this recently, and I was like, wow, I didn't know this was a thing outside of science fiction. They had an operation where the surgeon was in a different room. They were operated on by a robot, and the surgeon had their hands in a glove operating this robot clippy thing that could go and do this ridiculously fine whatever surgery through tiny little incisions in his. He went home the same day. Had like quite a serious operation, went home the same day, and there were these tiny little nicks on his body, right? Wow, LLM that, right? I want robots teaching me, showing me how to write the smallest amount of software that I wouldn't have thought of. You know, it's only that. Oh my goodness, of course it is, right?
I'm just troubled by the mention of Clippy, which makes me think of Microsoft's Clippy and surgery in the same sentence.
It looks like you're trying to remove an appendix.
But Holly, you said something about this with AI, that it seems to be rewarded on generating more.
Yeah.
More is more.
More is more.
I've got a suspicion that we're still talking about where we are today.
No, this is what I'm saying, where I want us to go. So we're currently, if we're going to burn the planet down and do LLMs, right, let's at least get something out of it. Every technology that I've seen, certainly in my working life, that has been awesome, made it easier to do the right stuff.
It's one of the things that makes me kind of nervous about where we're going is I think we're very close to losing the determinism that we're used to. We're losing version control even. If I version control the prompts and then feed the same prompt into the same LLM, I'm going to get a different result every time.
Because you need to version the world, yeah.
And I know I'm biased, but I've got a theory that what the next generation of programming is going to look like is an awful lot like test-driven development, because that's the way that we get to validate whether the software is still doing the same things.
But in order to get there, and I agree with you because you've already talked about this, in order to get to a point where modern software is TDD, we need to be good at TDD now, which we're not.
Yeah. It's a good argument for learning TDD.
Well, okay, we're all good on TDD. LLMs as tools that help me do a better job. In 1996, the gentleman to my left published a book. It's quite an influential book. It was a set of patterns, and it was a set of deterministic ways to manipulate software to do the same thing, but to have a different shape now. He called it refactoring, and it caught on. Within 5 years, a bunch of jokers, where Trisha now works, had taken that book and turned it into, they were automating all these things. So you didn't even have to do the things that Martin said. They'd already codified it so that you could press Alt-Enter, right? And it would do the thing.
And your code would still compile.
And your code would
would
still compile.
Be deterministic.
Because it was determined. It was taking an AST and doing exactly what. So Martin wrote the manual for the first IntelliJ, and then they went and built it.
The specification,
right? And this I was along for that ride. This to me was so exciting because now we had tools helping me do lifting so I could do thinking. And I don't want LLMs that are going to replace junior programmers. I want LLMs that are going to make programmers more awesome. And those are the tools that will, I think, that if we look at this in 10 years' time, 15 years' time, those will be the tools that completely change the industry, not the ones that purport to get rid of people.
I agree with you, and I often think about the LLM thing and the IDE thing because I'm a big fan of the IDE, and it's been very helpful for me as a developer. And it's funny because I tell people you should use the IDE, get to know your IDE. It generates the code for you, so you can do the thinking. And and then when people ask me about AI, I'm like, oh, don't use AI, it's rubbish. I'm like the old person.
You're not allowed to say that. Your product's got it in.
But I'm like the person going, no, you should compile it with text editor, you know. But I think that's a function of the fact that the AI stuff just isn't quite there yet. We can't trust it to do the thing we expect it to do.
But there are some things that you know, we're beginning to find handy. I mean, I mentioned the generating ideas stuff. Another is understanding code bases, particularly unfamiliar code bases. Again, that's another area we've been exploring with. Now, this is not Gen AI on its own. It's Gen AI in combination with things like loading ASTs into knowledge graphs and things of that kind. But it does help. I mean, because you know, if you're sitting faced with a code base of 1 million lines and you've got to make an adjustment, and you're not super familiar with how it all works, it can be very handy if you've got some tool you can interrogate to say, what happens to this data? How does this data flow through the program? And it can come back and say, you know, go to this line on this file and you'll see some important information as part of your look. And you look at it and maybe sometimes it points you to a completely useless place, but more often than not, if it points you to a good place, then that can help. And I think these are the kinds of potentials. It's not going to be about generating code, because I think we all understand that it's not about purely generating lines of code or function points or whatever it is. But there are other areas that are important. And I'm interested in what goes on and whether there's some possibilities around there. And one area that is quite interesting is searching unstructured information and trying to summarize it and point you to it. That does seem to be a very valid use case.
It's certainly powerful in that domain, but I just want to say I think it will be generating the code, but there was a test that somebody did in Google a little while ago where they connected two AIs and got them to talk together to solve a problem. And they invented a new language between them and nobody understood to communicate between them. I think it's not going to be very far into the future when whatever code they generate, we won't understand.
So I've got to say, in Holly's brilliant talk today, which if you weren't at, please catch it on TV, one of the things that you were talking about was using LLMs along with deterministic systems, as part of a tool set where it can help guide a bunch of things. And I was like, that thing, build me that thing, right? That's
the thing that I mean about TDD, really. So actually BDD. So you define the behavioral outcome that you want from the software in every respect, and the LLM fills in the gaps. That's what I think. My guess is we're on the verge, we're on the cusp of a 5GL, the next level of abstraction in terms of programming, and I think that's maybe what it might look like.
But I think the problem with that is that we're still not very good at understanding what the behavior of the system should be. When you speak to a lot of developers, and we do feel more comfortable just going, I'm just going to explore and see if I can get it to do what I want it to do, instead of thinking, right, what should it do when it has one of these, and when we fail in this sense, and what should the user expect to see? And although that's our job, I still think we're not great at that.
But that, I think that's the important part. That is what we as software developers can bring to the party. That's where the role goes, it seems to me, potentially.
We're effectively prompt engineering with syntax, right? So you type stuff in, you run it doesn't do quite what you meant, so you refine the prompt, which is the code, right? Until eventually it does what you want and you ship it.
Well, it's slightly different because the advantage with doing it with a executable specification is that it can verify that it does what you wanted it to. And without that, we can't really.
And I think Trisha's hit on one of the really important hazards of these systems, so that we do need to be aware of, which is at the moment, most of us are pretty terrible at defining what success looks like. And if we get it to compile, that is such a victory that we declare success. And we're like, look,
You've been using Rust, haven't you?
I have a whole pile of code and it compiles, I am done. And we can get to that point in about 10 seconds with an LLM. And so then there's this really tempting opportunity to skip the heavy lifting, to skip the heavy thinking of what does success look like, because we've got all this code and it looks so convincing and it looks so plausible, because the job of these systems at the moment is to make plausible, convincing looking code. And so we do need to have that discipline to step back and develop
Sorry,
those skills.
Farley, I'm going to keep going back to your talk. I had so much fun in that talk. So another thing that you pointed out in there is you can ask an LLM to solve a problem, and it generates all this stuff that if you're using Quarkus or using some of these frameworks, that their job is to get rid of all the boilerplate noise. What it generated is exactly the stuff you could immediately delete because what you wanted was the meat. And I've been talking about this a bit recently, is we're using LLMs wrong. An LLM cannot answer the question, what should I do now? An LLM can answer the question, when other people have been in a situation similar to the one I'm in, what sorts of things did they do next? It's really good at that. And again, you then have to qualify that with, when a bunch of people who are of average to minimal ability who post stuff on Stack Overflow saw the kind of thing that you might think by some really rough pattern matching looks a bit similar to what did they do next, and also feel free to make some stuff up because honestly we're fine, is actually the question it's answering.
So we see this at, I work at Gradle now, and we see this with Gradle. We were asking, should we use some sort of LLM thing to answer these common questions about how to use Gradle to do this stuff? And our engineer said, absolutely not. Because it's learning off Stack Overflow, and all the answers are wrong. There's all the bad examples of the code that you shouldn't be doing it that way.
They're the questions saying, why isn't this working? And this thing's hooning it all up and going, right, well, that looks like code, boom, boom, boom.
I do want to do a brief shout out for a talk that's coming on tomorrow morning by my colleague Birgitta Berkler, who has spent a lot of time really working with people that have been playing around with AI systems and trying to see what to use of them. That's how I felt like I'm the positive person on the panel. That's the reason I'm positive, is because I've had that contact with her and some of my colleagues who have found some useful things here. It's not the hype of sweeping software developers away, but it's a useful tool and it's worth trying to experiment. And I would urge people to do some experimentation. Part of our job needs to be always experimenting at how to do it better. And there is some interesting stuff in these tools. And the only way you find out whether it's going to be good for you is to give it a shot and try it.
I'm going to hard agree with that. I've seen Birgitta's, or at least an iteration of Birgitta's organ. It's brilliant, so please go to that. But I think, and I'm not like anti-LLM. I mean, anti-burning the planet. I'd like there to be a more efficient way to do it. But as I say, it's the LLM replacing people trope is the thing I'm going after. LLM as building tools that help us work better, reason better, iterate better, get feedback sooner, produce those hypotheses, those metaphors, those examples, those kind of riffing on things, help us riff better. I'm here for that.
I like it as a more advanced rubber duck. Because like I'm not co-located with a team anymore. I tend not to pair anymore. But the ChatGPT and JetBrains Assistant, those things have been quite helpful for me to say, like you were saying, explain this code to me, and it will explain it to me, and it may or may not be right, but it will point me in a different direction, or write me some tests, and I'm like, oh, okay, well now I've got somewhere else to go with that, or I sometimes generate my blog posts, like the first draft. But then I go, oh, God, that's all wrong, and delete all of that. It's a really good rubber duck for us to go, right, now I know what's wrong with this, now I know how to move forward.
So, yes, so Dr. Emily Bender, utter genius, she coined the phrase stochastic parrot. Mm-hmm. So an LLM is a stochastic parrot. It can parrot back phrases it heard in the room. Do you want to listen to the stochastic parrot, or do you want to listen to the people in the room who were having the conversation it overheard? And I call the listening to the LLM thing a parity error.
Yeah, well, actually, yeah. But I want to throw in a couple of other...
apologise for the jokes.
I'd like to throw in another angle of this as well. One of the things that was interesting to me about hearing about AI stuff, more than the generative stuff, was what had happened with playing Go. So I don't know whether you know, computers figured out how to play chess better than humans relatively long time ago. But a much harder game to play is Go, the Japanese game of white and black stones. And then eventually computers figured out how to play that better than humans. But what interestingly then happened is that the really good human players analyzed what the computers were doing and learnt more things about playing Go, more strategies for Go that had previously not been discovered. So I think one of the interesting things that will come out of a number of the AI things, and possibly more from the pattern matching side of AI than the generative side of AI, is we can actually start using those tools to begin to learn things. When we begin to say, when things start pattern matching and spotting a good pattern matcher that's doing something that we don't know how to figure out, the next step is to figure out what is it looking at. It may be looking at 7,000 parameters, but which are the ones that actually matter? And we start studying those. It's also part of the reason why I think that we shouldn't be, when people look into legislation and AIs, people shouldn't be saying necessarily we must not use AI for certain tasks, even though we shouldn't be using AI for certain tasks, like judging criminal cases or insurance contributions or whatever. But what we should instead say, you're not allowed to use any form of computer to judge these tasks that cannot explain its reasoning. And that there should be the mandatory need to be able to show your work and explain your reasoning. Because I think once we go down that path, actually some of these AI tools could improve our understanding of the world. And I think that would be really interesting.
I have a question for Holly. Because, and this is totally putting you on the spot and telling me to shut up, is completely fine. So Holly's background is quantum computing. And I've spent a bunch of time with this lady, and every time I spend time with Holly, my brain just hurts. All of the LLM stuff is based on classical computing, right? What's the quantum angle on large language learning?
That is totally putting me on the spot. And I think there's probably at least 3 answers.
Are they all overlaying each other simultaneously?
A little bit. When we look at quantum computing and quantum mechanics, as you say, it hurts our head. It is something that we cannot map to any of our normal experience. And so I think we assume that there must be some magical property to it, and that because it's non-deterministic, it must have consciousness. And that's actually very similar, thinking about it, to the trap that many of us fall into with LLMs, which is, this computer has surprised me, this computer is non-deterministic. There must be this higher force behind the LLM, and then we can step back and say, actually, no, it's a stochastic parrot, and it's doing some pattern matching that we weren't, possibly capable of ourselves. So I think that's one aspect, is that there's a tempting parallel that isn't actually real in terms of something higher, something bigger.
We're projecting some kind of meaning onto a space that just is a bunch of stuff.
Exactly, yeah. But then there is some really interesting work about quantum machine learning, because the thing that quantum computers are really good at is huge matrices. And if you stop and think for just a second, you'll think, wait a minute, huge matrices, I've heard that recently, where did I hear it? In the machine learning domain. So I think there's potentially some sort of mechanical augmentation that we can get from quantum computing.
Let's move on to take some of the questions from the audience. Thank you for submitting your questions. So I haven't got names, but I'll just read out the question. So, will power efficiency...
When you hear your question, just whoop really loudly.
Will power efficiency be a factor for future programming languages? And if so, which languages are today the most power efficient?
Who was in Sophie's talk this morning? She's amazing. I managed to talk to her afterwards. And basically, the whole gist of the talk is that we're the bottleneck. Like they are so the whole the chip world, the hardware world is so far ahead of what we can program to right now that we are totally the bottleneck. What's getting more efficient? I think languages where, right, so the shift I'm seeing, and this is completely making it up, I'm a software guy and totally out of my domain here. The shift I've been seeing as someone who's been a very happy Mac, Apple Silicon owner for the last several years, and probably won't upgrade my laptop for at least another 2 because it's brilliant, is system on a chip is becoming more prevalent, and more mini systems on a chip is becoming more prevalent, and locality of stuff is becoming more prevalent. So languages that lend themselves to, and this is right back to Martin Thompson's mechanical sympathy stuff, languages that lend themselves to compute and store in the same place. So something like Go, which has Go routines, if you do them properly, first class, tiny little compute engines that do stuff, have local memory, local store, local data structures, are ideal for having squillions of those running. Java, when you use all the Dudley concurrency stuff and not the threading stuff, again, can lend itself, the streaming APIs can lend themselves brilliantly to this kind of reactive APIs, can lend themselves to that kind of architecture.
The other thing about Java is the JVM is so smart. It's
the
going
JVM
to
is
optimize
ridiculous.
away your stupid code, and so it runs it very efficiently. It's one of the most power-efficient languages.
The JVM is one of the most brilliant bits of engineering in my lifetime. Like Java as a language is interesting, but that's not where the action is. The action is in the JVM. So I think languages like Rust, where you can reason about memory ownership, are interesting, but it's about affordances, right? They don't push you towards having mechanical sympathy. They push you towards having safety.
Yeah, when Martin and I were working and doing the mechanical sympathy thing, we used to say that you get an order of magnitude improvement like that by stop doing the stupid things. You get 2 orders of magnitude by thinking hard and stop doing the stupid things.
I remember a talk you gave, Dave, probably about well over a decade ago, and it was like, use dumb data structures. The whole talk was like, just use really stupid, simple, dumb data structures, and everything else goes away. And you had all this data, all these stats about how it was hitting like cache layers and whatever, and I was just sitting there going, we don't do this, do we?
The other thing that we found when we were working at LMAX with Martin is that the most efficient, high-performance, low-power code was clean code with small methods, readable with a small number of loops and if statements, and it was just good quality code.
Yeah.
If statements kill performance.
Yeah.
That's an interesting thing, because I mean, one of the things I detect out in the sort of broader world is a real pushback against small methods and clear code on the basis that it's bad for performance.
Yeah, no, it's not.
Which I have never believed even before I met Martin.
Show me the data, right? Honestly,
Exactly.
show me the data.
I mean, but that is another thing, though, because these things persist. In Java 1, small methods were bad for performance. Yeah. And we got that folk knowledge, and it's been 20 years.
Creating classes were bad for performance.
Well, yeah.
Don't new stuff up. That's killer.
And we haven't got rid of that folk knowledge. And on the internet, everything lives forever. And so now you still find bad performance advice that's 20 years old.
Even I was reviewing a new Java book, and it actually nulled out a variable and had a comment next to it for garbage collection. I was like, please don't do that, and definitely don't write the comment in a printed book for
Brian
garbage
wants 20
collection.
years of his career back.
And so that stuff not only is still persistent, but people are still repeating it in well-respected texts.
And we also have to remember that languages are often, for certain most of the applications I've been involved in, programming languages are not where the performance issues are. It's all I/O.
Yeah.
And of course, there's the business aspect as well, which is the problem isn't the programming language, the problem is on a higher level of we shouldn't have even written this program, but we didn't realize in time.
It's the Peter Drucker thing. I/O is interesting because I/O is a second order problem. You're right that I/O is inefficient, but I/O is saying, in lean terms, is waste, it's transport, right? The I/O is saying the thing I needed wasn't here when I needed it. So if we can start getting much more preemptive so that the things are there when we need them, suddenly a lot of the I/O concerns go away. So yes, I/O is expensive. Optimizing I/O, I think, is solving. It's the first loop learning. The second loop learning is how can I not need that I/O in the first place? Is to have the data move the data to the compute or move the compute to the data. When we start getting into SOC and these much smaller kind of Go routines or coroutine type CSP. Tony Hall got this right in 1974, right? When we get into this much more CSP type models, a lot of that locality sort of just disappears.
I think we dived into the weeds quite quickly, so I just want to sum up the stuff about the power efficiency. I think we ought to, if you want to save the planet, we need to start thinking about the power budgets of some of the software that we write. Because you said in your talk early today, writing more efficient software is a good way of being more efficient. The danger with that is it the Jevons rule?
Jevons paradox, yeah.
Yeah, the problem is that the more capacity we make it room for, the more we'll use it.
And back to are we even solving the right problem? Like, no code is faster than no code.
Yeah. Next question. If you have a particular situation where we have a Cat 3C aeroplane at an airport, the aeroplane is capable to land automatically. The situation is present in flight operations for... I'm going to skip that one, I can't read it, sorry.
Yes, you would totally just land the plane.
Yeah.
Did I hear, was it Cat 3 or Cat 3?
Cat 3.
It's
It's the accuracy of the auto-landing system.
Some planes you're not allowed to have cats on.
Well, that's what I was trying to figure out, because the internet is for cats and...
Planes are not.
There's cat planes, there's dog planes. You
Okay.
cannot put a cat on a dog plane. It's a type error.
So here's one. Given the writing state on international relationships, how can we connect software quality to software security?
They're the same thing.
Yeah.
That's all I got.
Yeah, I'll go with that as well.
Those are certainly very tightly connected.
So I don't talk about security, I talk about securability. Securability is the ability to reason about code from the perspective of security. It's easier to reason about small things. It's easier to reason about things that have a hard shell and a soft center. It's easier to reason about things where the protocol between the pieces is very explicit. Nat Price has this lovely phrase. He says, like, the protocol is the program, right? And when you start thinking like that, if you have small securable, there's a brilliant bit of mail processing software called Qmail. And Qmail is made up of tiny little pieces. Same guy wrote all of the pieces, the mail agent, the MTA, and the sender, and the blah, and the IMAP client. None of these pieces trust each other. They all assume everything else has been compromised. Right? And he's got it's about $100,000 bounty, and he's had it going since like the 90s. If you can find if you can penetrate this thing, it's a mail client. That's all it does, a mail client. If you can find and he's still got his $100,000. He's never paid it out.
Here's a good one to finish
Before
on.
we leave that one, though,
go ahead.
something I would say the very useful thing to do is pay attention to security issues. It doesn't have to be a big, complex process. So my colleague, Jim Gumbley, wrote an article, you can hunt for it on martinfowler.com, about threat modeling. It's not a big, fancy process thing. Basically, what he says is get together, maybe every couple of weeks, just for an hour or so, and go through some simple threat modeling process on your system to identify potential threats and how likely they're going to be and what you're going to do about them.
And
that's
keep your
something that
infrastructure
any
up to
team
date.
can do.
Yeah.
Last question. I expect your books are fed into the LLMs with a particularly heavy weight. Whoops, it jumped.
I have a get out here, which is don't publish a book. Talk about it, procrastinate. If you don't publish a book, they don't have you.
You don't have a book either.
Let me finish the question. I expect your books are fed into the LLMs with a particularly heavy weight. What are your thoughts on that?
I got asked about this the other day. Someone was saying to me, wouldn't it be really great if you could just ask an LLM to give you the answers to everything which is in your books? And I was like, are you paying a royalty for that? And they were like, no. Well, I mean, we wrote the books and we don't make a lot of money off the books, but when you sell a book, someone gives you a tiny amount of money. But when the LLMs consume it and then give out that stuff for free, nobody makes any money. We're doing all the work, and the LLMs are chewing up the planet and probably even giving the wrong answers from the wrong bits of the wrong books.
And I think
if you want to now make this musical, you've just described Spotify.
It's already happening with the LLMs, though.
But we do risk an information drought in the future, or actually sort of more like an information salination situation where you're surrounded by salt water, but there's nothing to drink. Because if the incentive for creators is removed, then the only thing you get is garbage. And so then that means that there's actually nothing to consume anymore.
Well, and I can't remember the name for this phenomenon, but there's already this recycling regurgitation thing. Is that huge amounts of information on the internet now is, on the web particularly, is hooning out from LLM, garbage hallucination generators, producing content, which then other LLMs or even the same LLMs are now taking back in as gospel and doing stuff with, and you're going to get towards this basically,
collapse
entropy scenario.
It is troubling because when I'm going out on looking for information, you just don't know necessarily where it comes from, and it does mean you tend to gravitate towards trusted names because. And all I can say is, you can tell we are actual real human beings. We are not LLMs. So you can at least trust what we say to not be automatically generated.
Martin is being sponsored by Boston Dynamics.
And all our content is generated by alcohol, which is just as reliable as an LLM.
Okay, I think our time is up. Thank you very much indeed.
I think our
If you'd
time
like to
is
give
very
our
much
panel a round of applause.